All right. So, see what we've got here. So here we've got, what kind of problem is it? Let's see, it's a proportion, right? Because there's no mean, it says proportion also. So the first thing was find the best point estimate. So my best point estimate is, again, whatever I got from my sample, my p-hat. So I had 323 out of 1,404 people, so 0.230, that is my point estimate. I want 3 sig figs here, guys, so 0.230. Since 0.230 is the same, well, okay, yeah, so so 0.230, that's what I want there. Find the margin of error. My margin of error is my critical value times square root of p hat q hat over n. So my critical value, it's a 90% confidence interval, it's proportion, so z. If you look that up, again, remember the z table is the bottom row of your t table. So you're going to look all the way down, and you'll see it's 1.645. This bottom row is your z table. And then multiply by square root of p hat q hat. And you can, if you don't have to write the zeros here since they're at the end if you don't want to, but if it was 0.231, you need to write 0.231. You guys see what I'm saying? And so my q hat would be 1 minus p hat. So 0.230 times 0.770 over n, 1,404. Square root that, and you get 0.0112 multiplied by my critical value, 1.645, and I get my error, margin of error, 0.018. So I will say find the margin of error. That means find E, like this, just so you're aware of it for the exam. And the last thing that I will ask you is to find the confidence interval. So you'll get a problem almost exactly like, well, not exactly like this, but the same sort of idea. Find the best point estimate, find the margin of error, find the confidence interval. And I want them in separate spots. You don't go put in this up here or this over there or this down there, you know, keep them separated. And then the last thing is the confidence interval itself. So the confidence interval is your p hat plus or minus your error, right? So p hat minus my error is 0.212, p hat plus my error is 0.248, in parentheses with a comma between it. Questions?
Yeah, I have one question.
Yeah.
So for like 0.248 and then 0.211,
Yep.
if there's like a 5 for the fourth sig, it's 1 and 3.
Yes.
Want us to round
Right.
that.
So if your error is, if you only do 3 sig figs here, you put 0.01 something something. You can totally do that. Yeah, I typically do want 3 sig figs here, but I cheated because I knew that this was going to be 3 decimal places here, so I knew this was going to be 3 decimal places also. But yeah, you could totally, and I probably would have preferred that you gave me 3 sig figs here. So Austin, you would have had what, 0.0185? Oh.
Yeah.
Oh. Yeah. So then that rounds to really 0.1. That's okay, because as long as you're within 1% of the answer, you're going to be fine. You know,
Okay.
so when you do this, you might end up with 0.211 or 0.213. That's totally not a big deal. That would be all right. As long as you show your work and it matches up with your work, then I'm all happy.
Right on.
Okay, good deal. Good question. Thank you for asking that. And then here's your lab problem 2. This is the last thing we'll do today. We have problems 3, 4, 5, and 6. I'm going to do 3, 4, 5, and 6 on Monday in the review session. So if you don't make it to the review session, make sure that you either watch the video for it so you can see those problems and do the problems and see the answers, or look at the board work PDFs at least so you can see the answers for those. All right, so here's problem number 2. I think these, so here we have, it's a proportion, right, because there's no word mean or average in here. And also you see this percentage, that's your p hat. And then, so it's going to be a z distribution. And it's also a confidence interval. However, it's a confidence interval because, how do you know it's a confidence interval? It says estimate. You guys see that one there? But it has a question. Anytime you have a confidence interval with a question, check and see if it's a find n problem. This one is. It's a how big of a sample, right? That's find n. So it means I have to have given you the error. Find within, you find the error. Within 2%, my error is 0.02. My critical value, let's see, 99% confidence level. So you look at that from the table, you get 2.576 or 2.575. Either one's fine, I don't care. And then your p-hat. P-hat's 36%. So p-hat's 36%, 0.36, then your q-hat is 0.64. All right, so then we pop these in here. All right, n equals my critical value over error squared times p-hat q-hat. So 2.576 over 0.02 squared times 0.36 times 0.64. And you get 3822.2. You have to have a whole number of people. You cannot survey a portion of a person, so you have to round, but you have to round up because this is the minimum sample size needed. So 3822 is not enough. You need at least this much. You have to round up to 3823. Make sure you pay attention to that because that will cost you a point or two. Questions on this one?
Yeah, I have a question. So
Yeah.
these problems are supposed to mimic the exam, right?
Yep.
So is like the main challenge for students on the exam is like figuring out which like problem, like what to do in them, not so much like the work itself. Like these seem like really easy.
Yeah, they are really easy. Yeah.
So it's just discerning for which.
Yeah. The hardest part is probably figuring out which problem is which. And you know, sometimes people screw up and the other thing people do is they get lazy or they mess up and they will use a Z table when they should use a T table or vice versa. So they get caught up in stuff and they'll forget and they'll get neglectful and they'll use a T instead of a Z. That's another super common problem I see people do. And I don't know whether you're doing that out of ignorance or doing that out of a mistake, so I have to assume that you don't know, right? And you lose points for that. So those are kind of the common things that people do is they use a T instead of a Z or vice versa, or they do the wrong type of problem. The other thing, again, that's going to happen pretty often is they'll do stuff where they will take a look at this and they will treat it like two samples, independent. So they'll treat it like this is the first sample, they'll find the mean and standard deviation of the top one, they'll find the mean and standard deviation of the bottom one, and that's completely wrong. You'll get the wrong answer. These are matched up. When they're matched up like this, then it's dependent and you have to subtract them, and then you just run a one-sample t-test on their differences. So that's the other thing that gets tricky is people, they don't see that these are dependent, right? This is 10 people. These are 10 people before and after. So this is the same person before and after. This is another person before and after. They're related, and they just don't see that. So those are two of the common mistakes. And again, I always get somebody who they're supposed to do a confidence interval and they do a hypothesis test for me, or vice versa. Or it's proportion and they try to do something with a mean, or vice versa. Those happen all the time. Okay, any other questions?